And the cool thing about the whole system, once you have it, is that now you can just implement a new action and then Hi guys, and welcome back to another informative GameDev video. My name is still Marcus, and I'm a solo game developer currently working on my game Raidborn, which is a first-person sandbox action RPG. If you want to find out more about it, check out my other videos. But let's come to today's video topic, which is AI. And in this video I will try to explain it very easily and that everybody understands it, even people who are not into the subject, who are not game developers. And I really want to show you what AI is, how it works, and ultimately that you have some knowledge about it, because when I was a gamer back then, when I had no idea of game development, I always found AI something mystical. What the hell is this? How does one create artificial intelligence? And that is what I would like to share with you today, that knowledge here. I will not go into detail how to actually create this, because that's just not the topic of the video. But let's start with what AI actually is. Because other than you may think, AI is not a simulation of humanoid behavior or animal behavior or whatever kind of creature you want to display in your games. It is actually an abstraction of that behavior. What does that mean? Well, first of all, one needs to understand that the resources or the processing power you have as a game developer is limited, because you're making a game for a wide variety of people. So creating a simulation of human behavior, which is highly complex and which most likely nobody has ever done. So you have to ask yourself the question, what do I want to display, and how do I want to make the player feel that it is a human or an animal, and that it seems like it has an intelligence when in fact it has no intelligence? Because think about it, you can't code the logic of how a human thinks. You can't create artificial brain in your game, so that is not possible. So the question you have to ask yourself is, how do I create that abstraction of human behavior that it still looks cool, interesting, and that you feel like this is like a human or an animal and that you can see it, but it is always an abstraction. That's very important to understand. The next question I would like to answer is, what makes actually a good AI? Why do you think in some games hey, the AI is good, and in others hey, the AI is bad? Well, ultimately, how smart an AI is depends on how much functionality you add to it and how good that functionality is. So that means that creating AI actually is similar to other things you create in games, like graphics or design. The more you put into it, the better it is going to be, and the more you polish it, and the more expertise the guy who's creating that has. An example for a good AI in a game is actually the game Fear from 2005, which not only uses a very cool system for AI, but also added quite a lot of functionality and scripts, which one of the programmers of the game once said. Another thing they did to make the AI feel more immersive and more realistic and more intelligent even, is that they communicated with each other. So they said something to each other, hey, there is an enemy, and stuff like that. Actually, that kind of stuff mostly is relatively random, but it does make the AI seem at least more intelligent, and that is what I just talked about a minute ago, that it is about abstraction, and it is about using tricks to make the player feel like the AI is actually alive, intelligent, and so on and so forth. By the way, a little fun fact here is that in my game Raidborn I actually used the same system as Fear did, which is called GOAP, and that stands for Goal-Oriented Action Planning, but we will talk about it a little later. Let me first talk about why would developers make AI more stupid than they would have to. And the simple answer for this is that if you would create an AI which is very intelligent and very fast reaction times and is aiming very well, for example in a shooter, then it's going to get more difficult, and that is the thing. Actually, you should not make your AI too intelligent, because then you get a problem with balancing and difficulty. And the thing you could do, which I think is pretty cool, but which most games don't do, is that you could actually increase or decrease the quality of your AI regarding on what difficulty state, like easy, medium, hard, and so on, you chose at the beginning or while you play. So now I think you have a good understanding of what AI basically is. You don't have a detailed understanding, but you have at least a rough understanding on the subject. Another thing you have to understand is, but which most people already know, is that AI coding is a very complex thing. In fact, in my game, AI makes like, I would say 35% of the whole coding tasks. And it's really a massive thing. I would compare it to like building all the levels or making all the assets for a game. That is nearly as much work as creating a good AI. Of course, it always depends. I mean, if you make a 2D platformer game, your AI code can be pretty simple, but we are talking about 3D, first-person or third-person shooters and more advanced games. But let's get a little bit more into detail here, because I think that is what you kind of came for, to really understand a little bit more. So I would like to give you an explanation of how that GOP system I talked about earlier works, and which I use in my own games as well. Although I changed it a little bit, so it's not actually the GOP system, and I made my own system, which is a little bit more simplified, but also a little bit more stable and simpler to use and more accessible, and has advantages but also disadvantages. But let's talk about how GOP actually works. As I mentioned already, GOP stands for Goal-Oriented Action Planning. But before we jump into the actual explanation, let me tell you what you normally use to create an AI. So normally you make different states like idle, walk around or patrol, or attack the enemy and stuff like that, or maybe go in cover, and you have all the different states. That's a thing which works and it's relatively organized, but it has a huge disadvantage. Because imagine you create this idle state, and then you create a patrol state, and then you create an attacking state. We have those 3 states. But now, with that state system, you have to code the conditions in which those states transition for every single state. So that means you say, hey, I'm in idle. If something blah blah blah, then patrol. If something else happens, then attack. And you have to do the same thing for patrol. If I'm in patrol state and I should not patrol anymore, then I go to idle. And if an enemy appears, then I go to action. And so on and so forth. And imagine you have 10 different states. Then it is a lot of work, because you have to code all those conditions. If something happened, and so on and so forth. So the problem here is, if I came up with a new action, then I have the problem of coding all the conditions as well. So that kind of limits me a little bit here. And that is where Go comes and solves the problem. Because Go works in a way that you don't have all its conditions, and how it works is that's similar than the state system. Yes, you again give them quite a lot of actions. But you have to imagine it more, it's like a pool of actions the AI has. And now you give those actions information. Like, for example, hey, action idle has a cost of 0 because you can do it all the time. And you also give the action information what effect it will have once it is completed. And then you have this large pool of different actions which have different costs and which have different effects. And then you have a goal on top of that. And the goal is, for example, stand around. And then it takes a look at this pool and searches every single action, and then compares their costs to each other, and then selects one. Actually, this whole system is not that easy. It's a very simplistic explanation of it, because you also have requirements for actions, for example. So for idle, this makes no sense. So let's take another action here. For example, I want to eat something, okay? And so let's say our goal is eat something, okay? Or I'm hungry and I want to eat something. And then you have the eat something action, which has a cost of 1 and has the effect that it lowers your hunger. So my goal is to lower the hunger, and then I have this action. So I want to do this action now, but now this action has an additional information, which is I need to have food in my inventory. And there is another action, look at that, and that is get food, okay? And it's just, imagine the NPC or AI is just walking around and finding food, and that is that get food action. That get food action has a cost of 1 as well, because it's relatively easy, has the effect of getting food, and that's it, has no requirements. So it now thinks, let's satisfy my hunger, but I first have to get food. So it creates a sequence of that. And the cool thing about the whole system, once you have it, is that now you can just implement a new action and then just, you know, tell the information to the system, like the cost, what effect it does have, and the requirements. And then that's it. The system will still work. You don't have to do all these conditions, because the system kind of knows the conditions there itself, because it can calculate the conditions from the costs. And by the way, just to make this cost attribute more understandable, imagine you have an additional action which is buy food, which has a cost of 1, and imagine the get food has a cost of 2, and now it makes sense that you buy food instead of trying to find food somewhere. And that is what the costs are for, if there are multiple ways of doing a certain thing. Of course, you have to balance and optimize those costs so that you get the behavior you want, because sometimes the AI will do something you did not want. Because, for example, if you want AI to do that particular thing, no matter the cost, then this gets a little bit tricky. But overall, that is the system. I hope I could explain it so that you can understand it, and the illustration in the background also help you understanding it. So ultimately, I can conclude this subject with that I really like the Go system. I'm actually in love with it, and I could not imagine creating a state machine again, especially for more complex AIs, which I always created. I never created a very simple 2D jump and run AI. I always went for the larger games for some weird reason, but it is how it is. And so I fell in love with the Go system here. Tell me what you think about the Go system. Tell me if I explained this well or was completely confusing and bad. Tell me if you learned something and what you think about the whole video, and so on and so forth. You can tell me just all your thoughts, and I read everything, of course, and I will also try to improve my videos from your feedback. And yeah, last but not least, as always guys, stay cool, have a wonderful day, and see you in the next video.